Okay kids, so now I'm back, and the beauty of doing these as 3 separate videos is they're a little bit smaller, so it'll make it easier if you want to watch these additionally at another time to see these examples, and they're broken up to make it easier for you to pause, etc. So I'm going to take you through example 610, and then I'll do the same thing with the final example. I'll do it as a separate video. So it says use the summation equation to determine the enthalpy of the following reaction. So step 1 is we're going to go back to this reference booklet, looking at pages 5 and 6, and we're going to look up the values for each one of these substances, remembering that these are listed in alphabetical order. So here's my section for nitrogen, and I'm looking for NH3 gas. So as I come down the nitrogen column, and I'll find it, it's the third one down, NH3 gas, and it's listed as negative 46.1. So what I suggest you do is then come right here above the NH3 gas, the ammonia gas, and write 46.1. And then oxygen is an element, and I'll show it to you just to prove it to you. You can look them up if you want to. But when you're looking up the elements, they will be listed as 0, or you simply know that the element in its normal state will be a value of 0. So there's O2 gas as 0. So we'll write that one in. Then we're going to go back to nitrogen to find NO. So here's the nitrogen list again. NO gas, 90.3. And last but not least, H2O, but specifically as a gas. So we'll go over here to hydrogen. Here we go, on this side. We'll come down and find H2O, but we want H2O gas, negative 241.8. Now the reason that I recommend that you write these in above each substance is then you can set your booklet aside and you don't need it anymore for the rest of the process. And now you're going to go ahead and set up your delta H equation. So it's going to be the sum of the products minus the sum of the reactants. And what I often do is tell kids, make a little line like that emphasizing where the products begin. Because now you're going to go ahead and for each one you're going to take the coefficient times the associated delta H that you looked up in the booklet. So it's going to be 4 times 90.3 plus, because it's the sum of, now go on to the next one, 6 times negative 241.8, and just stretch it out so you keep your signs really obvious and it makes it easy for you when you go to set this up in the calculator. Close the parentheses. I've now completed the products. Sum of the products minus, now we jump to the front, sum of the reactants. Coefficient of 4 times negative 46.1. On to the next one, plus 5 times 0. Now, immediately you're thinking to yourself, Mrs. Alvarez, why are you putting a 5 times 0 in there? It doesn't make any difference. Well, because it's handy then when you're done to be able to go 1, 2, 3, 4 things, 1, 2, 3, 4 things. I didn't miss anything. And at that point, if you want to, you can just kind of go like that and eliminate it from part of the calculation. And now you're ready to do the actual calculator work. And we'll see if I can slide this in here underneath so you can actually see the screen as I do the calculation. Because setting up the calculator properly is half the battle in these. So starting as we work across the first one, we don't really need to worry about parentheses. We're going to need it for the second one though. We can go straight across the string. So 4 times 90.3 plus 6 times negative 241.8 minus, now that's where I need my parentheses, 4 times negative 46.1, close parentheses, equals, and my answer should be negative 905.2, and in fact it is. And then my units are the same units as we saw on the booklet, so let's go back to the booklet, looking at the top of the column right here, kilojoules per mole. Now, notice I only wrote kilojoules. I didn't write kilojoules per mole, and I just said, look in your booklet and you can see that it's in kilojoules per mole. Well, why? Because each one of these values is kilojoules per mole, but this 4 is in fact the number of moles. Oh, it's this one actually. So if I multiply the number of moles by kilojoules per mole, the moles cancel out and my final answer should be just kilojoules. Now, you might notice that I used parentheses for this term right here. I did minus parentheses 4 times negative 46.1 close parentheses. You could actually do this calculation without that set of parentheses and still get the right answer. Where you'll run into trouble is when you have an additional term that doesn't drop out. So that's why I said to go ahead and use parentheses for that second piece when you get to the minus. So you want to go minus, open your parentheses, do the whole term, close the parentheses, equals, and you'll be all set. Again, what you want to get away from, just like in the Hess's Law problem up here, we didn't want to be calculating these and writing the answer off to the side, then adding them up. When we're in a problem like this, what you don't want to be doing is calculating this, writing it up here, calculating this, writing it up here, and then trying to do the calculation by re-entry. That re-entry is what often causes the calculator mistakes. So make sure you take the time to not only set this up, but also go back and practice with the calculator. Look up all your values first, products minus reactants, and then your calculator work. Next will be example 611.